Today we're going to talk about solving quadratics by taking square roots. When you're solving quadratic equations, it's good to have a couple different tools in your toolbox. Taking square roots is just one of the methods that you can use. The one that we talked about previously was solving quadratics by factoring. Factoring is great, but it doesn't always work, so it's good to have some alternatives. In number 1, you might notice that there's only one variable in the problem. So, if you want to solve for a variable, the rule of thumb is that you will isolate that variable, get it all by itself. In order to do this, we're going to use the opposite operation. If n squared and 3 are being subtracted, we will add 3 to both sides so that we can remove the 3 on the left-hand side and move it to the right-hand side. Now we've got n squared equal to 36. At this point, I want n, not n squared. And just like with any other solving problem, we're going to use the opposite operation, or the inverse operation. So what is the inverse of squaring something? Taking the square root. Now there's something you need to know before you just jump in and put the square root in there. If you add a square root into a problem, whatever you do to one side, you've got to do the same thing to the other side. But if you put the square root in the problem, you also have to put a plus or minus, because there are always 2 possible answers for every square root. Now the square root of n squared is going to just give me n. The square root of 36 is 6. And you can see I've got this plus or minus sign. Sometimes you're going to see the answer actually separated, and you'll see the positive 6 and the negative 6 written separately. I'll accept it either way. Number 2 is the same type of problem, but we have a couple steps to get the n squared by itself. The first step would be to add 1 to both sides. So I've got 4n squared equal to 49. Now n squared is multiplied times 4, so I'm going to divide 4 on both sides. I know it's tempting, if you're using a calculator, to do this division and write the decimal down, but I want to encourage you, don't ever put a decimal into a problem unless the instructions tell you to give the decimal answer. We're going to leave things as fractions, and we're going to deal with them as fractions, and we'll simplify them that way. 49 divided by 4 doesn't simplify. But over here, I want to solve for just n. n is currently squared. I'll use the inverse operation. I'm going to take the square root of both sides. Anytime you put the square root into the problem, you also have to put a plus or minus sign. When you're taking the square root of a fraction, you're going to take the square root of the top number and the bottom number separately. The square root of 49 is 7, and the square root of 4 is 2. Number 3 looks very similar to number 2. We're going to start this problem the same way. Add 6 to both sides. That gives us 7r squared equals 196. Since 7 and r squared are multiplied, I will divide by 7 on both sides. So now r squared is equal to 28. Since I want r and not r squared, I will take the square root of both sides, and I'm going to add a plus or minus sign on this answer side. So I've got r equals plus or minus the square root of 28. 28 is not a perfect square, like the previous problems. So I'm going to have to use the method that we practiced, I guess, almost 2 weeks ago, where we break down our 28. The smallest prime number that can go into 28 is 2. It goes 14 times. 2 also divides into 14 7 times, and 7 divides into 7 1. Anything that shows up twice will get to come out, and anything that does not show up twice remains inside. So my final answer is going to be plus or minus 2 square root of 7. And like I said before, sometimes you will see that answer separated. This is correct, but just know that sometimes you will see 2 square root of 7, comma, negative 2 square root of 7. These mean the same thing. Number 4. I'm going to isolate my r squared, get it all by itself, by adding 4 to both sides. I've got r squared equal to negative 3. Now I don't want r squared, I just want r. So I'll take the square root of both sides and I'll add a plus or minus sign. So r is equal to plus or minus the square root of negative 3. Negative 3 is not a perfect square, and it can't be broken down, so nothing's coming out. But I do need to deal with this negative. Anytime you have a negative underneath a square root, an I comes out. So my final answer is going to be r equals plus or minus I square root of 3. These last two examples look more complicated, but the process is exactly the same. Even though I have this parentheses in number 5, that parentheses is squared. I want to solve for x, and I need to get x all by itself. So again, I just start peeling the layers of this onion away. Start with things that are furthest away from the x, and then move closer to the x as you can. Start by adding 19. This gives me x minus 1 squared equal to 100. Now I can't get to that x without getting rid of this square. If you ever need to get rid of something squared, you take the square root. And whatever you do to one side, you do the same thing to the other. And if you put a square root into the problem, you also need to put a plus or minus sign. Now when you take the square root of a parentheses squared, the inside of the parentheses is your answer. So the answer to this left-hand side is x minus 1. The square root of 100 is 10. Now in a problem like this, I am going to add 1 to both sides so that I can move it to the other side. But you're going to want to put this 1 in front of the plus or minus sign. So I've got x equals 1 plus or minus 10. Now I'm not done because I actually can solve this. This is going to result in two answers. The first one would be 1 plus 10, which is 11. And the second one would be 1 minus 10, which is negative 9. Number 6, I want to solve for x. I've got this trinomial, and typically we would think that it would be worth bringing the 7 over here and setting it equal to 0 and solving like by factoring, but I want to show you a trick. This is a perfect square trinomial. How would I know that? My first term is x squared, and my last term is a perfect square, 25. In a case like this, if you can take the square root, 5, and you can double it and get the middle term, then you've got a perfect square trinomial. And what that means is that it factors into two identical parentheses. And here's why that's cool. X minus 5, x minus 5. Anytime it factors into two identical parentheses, you can write them as a single parentheses squared. And if you can write them as a single parentheses squared, you can take the square root of both sides and get rid of that that square. Now I have x minus 5 equals plus or minus the square root of 7. The final step would be to add 5 to both sides. So x equals 5 plus or minus the square root of 7. This is your final answer, but don't forget, sometimes you will see this separated as 5 plus the square root of 7 and 5 minus the square root of 7. These just mean the same thing.